everyone, welcome to my channel. Today I am going to teach principle of mathematical induction, that is chapter number 4. Now exercise 4.1, the first question is prove by using principle of mathematical induction, that is 1 plus 3 square plus so on up to 3 raised to n minus 1 is equal to 3 raised to n minus 1 divided by 2. Now I have solved in a very easy method. Okay, so this part is considered as a LHS equal to, and this part is considered as a RHS. Now there are three conditions to prove this. The conditions are, first you need to take n is equal to 1, then you need to take n is equal to k. Now you have to prove that n is equal to k plus 1 is also true. If these three conditions satisfy, then this mathematical induction is proved. So first condition is for n is equal to 1. So as I have told you, I have taken LHS and RHS. So here in the LHS part, 3 raised to n minus 1. So in place of n, I am going to write 1. So 3 raised to 1 minus 1. 3 raised to 1 minus 1. So it is 0. So 3 raised to 0 is 1. Now RHS part. In the RHS part, 3 raised to n minus 1 divided by 2. In place of n, I am going to write 1. So 3 raised to 1 minus 1. So 3 minus 1 is 2 divided by 2. These two get cancelled. It is 1. So LHS is equal to RHS. Therefore P of n is true for all n values belonging to natural numbers. So first condition is proved. So second one is for n is equal to k. In LHS part and RHS part, wherever is n, you need to write k. So here 1 plus 3 square plus so on up to 3 raised to n minus 1. So in place of n, I am going to write a k. So it is k minus 1. On the RHS side, 3 raised to n minus 1 divided by 2. So here in place of n, I am writing k. So 3 raised to k minus 1 divided by 2. So therefore P of k is also true for same positive integer. Now we shall prove that P of k plus 1 is also true. The final condition. So what I have done is I have taken LHS. Okay, in the LHS part I have written 1 plus 3 square plus so on up to, in place of n, I am going to write k plus 1. Fine. In place of n, I am going to write 3 raised to k plus 1 minus 1. Okay, observe carefully. So plus 1 minus 1 get cancelled. So what is remained here? 3 raised to k is remaining. Now in the next step, what I have done is, what is 3 raised to k before term? It is 3 raised to k minus 1. So 3 raised to k, the before term is 3 raised to k minus 1. Now this whole term from here, it is 3 raised to k minus 1 divided by 2. So instead of this, I have written this one, 3 raised to k minus 1 divided by 2. I have taken from here, you can see. Fine. Plus 3 raised to k, it is here. Okay, now I am going to take LCM, multiply this 2 here. So 3 raised to k. Okay, so 3 raised to k minus 1 plus 2 into 3 raised to k divided by 2. Now you can see 3 raised to k plus 2 times of 3 raised to k will become 3. So it is 3 into 3 raised to k minus 1 divided by 2. Now 3 is nothing but 3 raised to 1. Fine. Now when bases are same, add the powers. You might have studied in lower classes. Fine. Now I have written 3 raised to k plus 1 minus 1 divided by 2. Now this k plus 1, as I have told you, we have to replace by n. So this proves that 3 raised to k plus 1 minus 1 upon 2 is also true. So we have satisfied all the three conditions of the mathematical induction. So this completes your first answer. Let's move on to the next sum. Second question is 1 cube plus 2 cube plus 3 cube plus so on up to n cube is equal to n into n plus 1 divided by 2 whole square. Now this is LHS part and this is RHS part. Fine. Now for n is equal to 1, LHS part. So LHS part is still here. So in place of n, I am going to substitute 1. So 1 cube is how much? 1. Now in the RHS part, wherever there is a n, I am going to substitute 1. So 1 plus 1 divided by 2. 1 plus 1 is 2. So 2 divided by 2 get cancelled. So 1 square is again a 1. So LHS is equal to RHS. Therefore P of n is true for all n belongs to n, that is natural numbers. Now second condition is for n is equal to k. In the LHS part, where there is a n, I must substitute k. So it will become k cube. Now in the RHS part, wherever there is a n, I must write a k. So k into k plus 1 divided by 2 whole square. Fine. Now third condition. So we shall prove that P of k plus 1 is also true. Here P of k is a true. Okay. So now in the third condition we shall prove that P of k plus 1 is also true. Now in the LHS part, where there is a n, I must write k plus 1. Okay, 1 cube plus 2 cube plus 3 cube so on up to k plus 1 whole cube. In the second line, what I have done is, before this k plus 1, I will get k cube. But here, from here till here, I have already proved in the second condition, that is k into k plus 1 divided by 2 whole square. You can see here. 1 cube till k cube is this much. So this I am going to write here. This is very important. Plus k plus 1 whole cube. Now here what I am going to do is k square, 2 square is 4, k plus 1 square. For all the terms I have square plus k plus 1 whole cube. Now I am going to take LCM. Now what is LCM? So this 4 I am going to multiply cross. Okay. So here k square write as it is, k plus 1 whole square plus this 4 I am multiplying here. You can see here 4. 4 k plus 1 whole cube whole divided by 4. Here it was not there. Fine. Now I am going to take common. In this 2 what is common? K plus 1 whole square is common. So what is remaining? K square is remaining plus 4 is remaining and 1 k plus 1 is remaining. Because k plus 1 whole square is taken common, so 1 k plus 1 is remaining now. Now here k square plus 4 into k is 4k plus 4 ones are 4. Now this whole term is a quadratic equation. Now you need to factorize this. Fine. In the lower classes you have studied factorization. Fine. Now 2 2s are 4, 2 plus 2 is 4. So the factorizing number is k plus 2 whole square. So this is the factorization of this. Okay. Now this I have written as it is, this 4 also I have written as it is. Finally, k plus 1 whole square I have written as it is. Now instead of k plus 2, I have written k plus 1 plus 1. Now why did I write 1 plus 1? Because I have to replace k plus 1 by n. So k plus 1 is nothing but n. Now k plus 1 is n plus 1 whole square divided by 4 is also true. This proves the complete second question of a mathematical induction. Now the fourth question is 1, 2, 3 plus 2 into 3 into 4 plus so on up to n into n plus 1 n plus 2 is equal to n into n plus 1 n plus 2 n plus 3 divided by 4. We need to prove this. Now this part is LHS, after is equal to all this part is RHS. Fine. Now the first condition is for n is equal to 1. Now in the LHS part, from here till here, where there is a n, I am going to substitute 1. Okay, here there is a n, so I have substituted 1. Here there is a n, I have substituted 1, 1 plus 1. Now here there is a n, so I have substituted 1. So 1 plus 1 is 2, 1 plus 2 is 3, 2 3s are 6, 6 1s are 6. Okay, in the RHS part, wherever there is a n, I am going to substitute 1. So 1 plus 1, 1 plus 2, 1 plus 3 divided by 4. 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 1 is 4 divided by 4. 4 and 4 get cancelled, 2 3s are 6, 6 1s are 6. So LHS is equal to RHS. Fine. Now P of n is true for all n belongs to natural numbers. Now the second condition is for n is equal to k. Wherever there is a n, I must substitute k. Okay, so k plus 1, k plus 2 is equal to, on the RHS part, k plus 1, k plus 2, k plus 3 divided by 4. LHS and RHS, both the places I have substituted k. Therefore, P of k is also true. Now we shall prove that P of k plus 1 is also true. In the LHS part, where there is a n, I have to substitute k plus 1. Here also k plus 1, here also k plus 1. Okay, this remains as it is. K plus 1 I have written as it is. K plus 1 plus 1 is nothing but 2. So k plus 2. 1 plus 2 is 3. So it is k plus 3. Fine. Now after this, this is whatever this is there before the term. K plus 1, k plus 2, k plus 3, before term is k plus 1, k plus 2. Fine. So 1 into 2 into 3 plus so on up to k into k plus 1, k plus 2. This term is nothing but condition number 2. Here the RHS part is k into k plus 1, k plus 2, k plus 3 divided by 4. So this term I have replaced by this. This is the most important step in mathematical induction. Many students get confused how this step has come from this step to this step and from this step to this. Okay. From this step, the previous term will become this. From this, the condition number 2 is RHS part. So I have written here. This you need to write as it is. Now in this 2, I am going to take common. The common is k plus 1, k plus 2, k plus 3. What is remaining? Here k is remaining. Here 4 is remaining. So I have written k by 4. Plus nothing is remaining here. Nothing in the sense it is 1. Now I am going to take LCM. LCM means this 4 ones are 4. Okay, this k plus 1, k plus 2, k plus 3 I have written as it is. Now if I multiply this, k plus 4. Now denominator part is 4. Fine. Now k plus 1 as it is. K plus 2 can be written as k plus 1 plus 1. 3 can be written as 1 plus 2. 4 can be written as 1 plus 3. So in place of k plus 1, if I replace n, then I will get the RHS part. So this proves that k plus 1 is also true. I hope you are understanding this mathematical induction sum very clearly. Thank you very much for watching, and keep watching other videos for other exercise and sums.